Woohoo! We're back. Identification test. Yay! How exciting can this be? So in this lecture video, we're going to focus on the instrumental identification test. So this is the equipment-based versions of the what should be very quick and easy chemical identification test. So the chemical identification test that we talked about last time, we said came from this general reference of the USPNF 191. And under 191, we're going to see a list of cations and anions that can be tested. As I go through the list, I'm just going to call these out. We've got acetate, which is going to be an anion, aluminum, which is a cation, ammonium, which is a cation, antimony, which is a cation, barium is a cation, benzoate. This is actually going to be an anion in a way. The bicarbonate is going to be an anion. So we see a mix of all of these. The bismuth is going to be a cation. And as we go through the list, we can assign these as cations or anions. That is not really the purpose of what this class is. It's not really the purpose of what I would put onto a test or a quiz. But just know there's representation of both. As I go through bisulfite, borate and bromide, calcium, carbonate, chlorate, chloride, which has a big change to read. Ding, ding. There's my triangles, right? Citrate, cobalt, copper, hypophosphite, iodide, iron, lactate, lead, lithium, magnesium, manganese and mercury, nitrates, nitrites, oxalates, permanganate, peroxide, phosphate, potassium, salicylate, silver, sodium, sulfate, sulfite, tartrate, thiocyanate, thiosulfate, and zinc. So those are the cations and anions that the identification test is going to reference to. If the compound that I'm working with has any of those, then there's probably going to be a 191 reference, and that 191 I'm going to flip to. They're in alphabetical order. I find what's present, what I need to test, and it will tell me those directions. So, for instance, if there was tartrate, and I think that I'm working with tartaric acid, then dissolve a few milligrams of that salt into 2 drops of sodium metaperodate solution. So, again, should be very short, should be very sweet, should be very simple. Add 1 drop of sulfuric acid, and 5 minutes, a few drops of sulfuric acid. And then after that, a few drops of fuchsin sulfurous acid, TS, in a reddish pink color is produced within 15 minutes. So this one's going to take more than 1 reagent. That's fine. I can order all of these reagents, by the way, through a chemical supplier. They can already be pre-made. I don't really have to make them myself. I'm just going to pay a little bit more for those because they are like standardized, legit USP reagent type of stuff. And if I want to make them myself, I can, because there's recipes that go along with this. All right, but either way, there's the chemical identification test. So after that, we see a section, and this section in 191 is titled Instrumental Identification Test. So this is letting you know that if you do an instrument, you're going to have to go to this validation section. Gives you a hyperlink for that. It says 1225, right there it is. 1225, validation, data elements required for validation, category 4. So we're going to talk about that in a different video, just not right now. But this is the idea that instruments have to be validated and approved before we actually use them. And then under the instrumental identification test, there's going to be a list of equipment that typically is going to be found in this section. Again, it is not all inclusive, but it's there. So I want to take a few minutes, talk about some of these instrumental pieces that we might be expected to use in the identification. and really focus in on one, because I think one makes perfect sense in a way if you know what that machine does. All right, so under 191, we see this section, instrumental identification test, blah, 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 blah. Okay, so whatever. And then I go to 191, I'm going to sum it up. So 191 is going to say, hey, listen, folks, you do have an instrumental piece that you are more than welcome to do. Here are the kind of pieces that we're going to say is okay to use for this purpose that we think is relevant, and it will list those pieces of equipment for you in this section. Next up is that they don't specifically say it, but they can be used instead of chemical test versions if you think that it's an option for your lab. So for instance, if there is a sodium test, and I don't want to do that sodium test with a chemical reagent, but I want to do a sodium test using a piece of equipment, then you are more than welcome to do that in exchange for the chemical test, because the USPNF actually tells me that. That's verbatim. They can be used instead of the chemical test versions if it is an option that you have in your laboratory that you want to do. Sometimes, though, they like to reserve the equipment for more formal testing, and they like the chemical test because those are simple and easy and quick, and that's just what it is. But if the instrument is there and it's available and you want to use it, the USPNF is not going to tell you not to do it, all right? Next up, the only criteria that they have, or one of them, the main one, is that it's got to be validated. So if you don't validate the methods and prove that they work, then you've got a problem, because if you don't validate it and prove that it works with something with known maybe sodium in it, like run something that you know good and well has sodium in it, that machine better say it's got sodium in it. If it does, then somewhat you've done a validation step. Then after that, you can run these samples that are submitted to the lab where you have to report, is there sodium present, yes or no? Because those are unknowns. You don't really know what those are. Or they're sent to you with a name and you think you might know what they are because it's on the label, but you're confirming that that label is correct. You're confirming that what's on the inside is actually what's supposed to be present. So that's the term of validation, making sure the instrument's working the proper way, and often you are using a standard in order to complete that validation process. Next up, the paragraph is going to talk about these libraries. The libraries can be used for references. So some of the instrumentation, and you will see that when you do some of the tests in our lab, but some of them will have a computer library in place. And what that means is that the instrument will run something, and the instrument will then compare that signal to a database, and it will kind of play match game. And it will say, listen, based on what this instrument sees and based on the data that was generated, we can match game what's in our database, and we can say, yeah, this looks like this, and maybe a complete name shows up on the computer software, and it will identify what that thing is supposed to be. If so, that is perfectly fine. So those libraries are approved, and those libraries, you want to make sure and you want to double check everything when you do use them, just like everything else. Next, the other thing that we've got to realize is that if we're in the lab and we're using some of the instrumentation that has been validated, it's had to go through a formal process that we've laid out clearly, maybe in an SOP, right? And that validation process is going to probably require me to run things that we know should be a positive result. And those things that should be a positive result very often are going to be referenced as a USP reference standard. So these are things that I'm going to purchase. They are very high quality. They are USP approved, and we will take that material, whatever that material might be. We will run that material or analyze that material in an instrument. We know that it should be present. It's been approved. It's been tested before I even receive it. And then that way we are ensuring, yes, we are using the highest quality standards that we can in order to validate our instrumentation and ensure that everything is going according to plan. All right, so USP standards, though, I want you to kind of think about these USP standards, what does the USP stand for? Ka-ching, ka-ching, ka-ching. That's what they stand for. So these are sometimes very expensive standards for just a very, very tiny amount of material. Some of the instrumentation pieces that are listed in this category of 191. X-ray fluorescence is going to be one. We don't do a lot with X-ray fluorescence in our program. It's just something that we don't run across or that we need very often. And we're not going to waste money on things that we're only going to use once or twice. So X-ray fluorescence we do not have in-house, but it is a piece of instrumentation that can be used for anion or cation identification or some of the chemical identification tests. Number 2 is atomic spectroscopy. Any version of atomic spectroscopy, and we abbreviate this as AA. So any version of atomic spectroscopy in-house can be used. And we do have one of these in the Chemtech lab, and that one that we have is a atomic absorption spectrometer. So that's why I say we abbreviate this as AA. The first A is for atomic, and the second A is for absorption. So this is the idea that I have a metal, and that metal might be swimming around in solution, but as long as it's a metal, we probably can analyze it on the AA. So think of things like manganese, magnesium, sodium, lead, chromium, all of those kind of middle transition elements of the periodic table, and everything in the first 2 columns can be analyzed on an atomic absorption or just a slight modification atomic emission spectrometer. So AA or AE, depending on the setting that we're using. More about that in our instrumentation course. So atomic absorption, we do have. We can complete these tests in the USPNFs. Not an issue here at all. Next up are inductively coupled plasma, optical emission spectroscopy, and inductively coupled plasma mass spectrometry. We abbreviate this, of course, as ICP-OES and then ICP-MS. So either one of these instruments can also be used for metal analysis. So folks, this section is really all about cations. That's what section number 2 is all about. So the ICP-OES, the ICP-MS, I want you to think of those as atomic absorption, but on steroids. So they're a little bit better. They're way better, actually. They can go lower. So we're looking at part per billion levels instead of part per million levels. So they're way more sensitive. They're way more expensive. We currently do have an ICP in-house. It's not operational right now because a major piece of that instrument has malfunctioned. And it's just not been on a priority list really for us, as it was a donated piece of equipment. So sooner or later we'll get that back up and running if it's not already running by the time that you watch this video. But we do have ICP capability, or we should have ICP capability at least. All right. Next up, section number 3 is ion chromatography. We abbreviate this as an IC. And the ion chromatography can actually be used for both worlds of ions. So if you go back and take a look at some of those definitions, we said we could have cations, which are positively charged things, and we could have anions, which are negatively charged things. So ion chromatography can be adapted to do both. So we can separate and find positive things, and we can separate and find negative things. So if it's something like sodium, let's say that I've got sodium that I want to analyze, folks. So there is a chemical ID test for sodium. It's a couple of reagents. I add it in. I see what's there. I see what's not. I write down the observations. Is a precipitate form? I mean, those are the types of things that the chemical version of the ID test is going to do. If I didn't want to do the chemical ID test, though, I could use an AA or I could use an ICP system, because those are built to measure positive pieces. So if I had a method in place, a standard operating procedure approved, that allows me to take a bunch of samples and get them prepped, and then walk all of those samples over to that instrument and quickly dip the sample tubes into those samples, or let an auto sampler take over for me, then that machine can take over and it can automate the process, so that way I don't have to be there for 60 samples or whatever the auto sampler is going to hold. I can walk off, let the machine do what it needs to do, and then I go focus on another test that I need to perform. So a sodium can be analyzed with AA or ICP. Next up, ion chromatography. So I can take an IC system and I can make sure that it sees positive pieces, and sodium would be a positive piece. So I can actually take those same samples and I can then go over to the IC system and I can be like, hey, IC, I want you to run all of these, please. And I can load up however many the auto sampler can hold, and then I allow that instrument to take over, and it will tell me if sodium is present, and if so, how much is there. So I can do one more step better than chemical ID test here, which is another positive thing about the instrumentation pieces. So here it is all about, yes, I can ID it and I can say, yep, it's there, or no, it's not. And then if it is there, if, it's not a requirement though, but if I need to report a concentration of those particular cations or those particular anions, I can do that through instrumentation pieces. That's something that I can't quite do with a qualitative analysis scheme or a few reagents added to drops of test tube, see what color it changes. That's something that I can't quite accomplish just using those observational based tests. But instrumentation, I can. It's not a requirement though for the ID category, but I could do it if I wanted. Next up, number 4 is liquid chromatography. We abbreviate that as LC, but that really now know is HPLC. High performance liquid chromatography is what that stands for. But liquid chromatography, very commonly found in the identification pieces of some of these monographs. So I can take this sample, I can run this sample on a machine, I can see if the presence of that particular piece is there, and then what the LC will actually allow me to see is everything that we would classify as an impurity. So not only would I see what I'm supposed to be looking for, but anything else that might be present that's coming along that's deemed an impurity, I'll be able to see some of those things as well. Next up, number 5 is Raman spectroscopy. We don't really do too much with that at all. We just don't really even talk about it or discuss it, actually. And then next is number 6, and that's mid-infrared spectroscopy. We do quite a bit with this instrument, and this instrument is also just simply regarded as infrared sometimes. So infrared or FTIR, Fourier transform infrared, all of those really talk about the same types of processes. So Fourier, F-O-U-R-I-E-R, Fourier transform for FTIR. So this is the idea that certain compounds give us certain signals, and those signals need to be present in our instrumentation as we run them if they are present. So we simply take a sample, add it to the FTIR or infrared, and we allow that thing to generate a signal, and then that machine will compare that signal to, yet again, a database that we've already talked about. So as far as like one of these entries of ion chromatography, one of the entries of an instrument goes, here is ion chromatography as an example. It says identification using ion chromatography. Ion chromatography can be used to identify a number of anions and cations found in drug substances. So again, proper method. I can use this if I don't want to do chemical ID tests. Apparatus says you need an analyte detection that will typically utilize suppressed conductivity, whatever that means. That's, again, instrumentation courses. Although other detection methods are possible. The ion exchange column must be capable of separating the analyte from any other ions of the same charge. So, for instance, if I get potassium, which is a positive one, and I have sodium, which is a positive one, will the machine see sodium if that's what I want to run? Yes or no? And then is the machine able to really separate this positive one, sodium, from something that carries a similar charge, which maybe would be potassium, that also carries positive one, right? That's what this is all about. So that's why it says this is proper as long as you can separate that positive 1 piece from all the other things that are present, because you want to measure the amount of sodium, not everything else in the sample. Maybe we're just only focused on this one thing. That's a possibility, right? Same story with like magnesium, which is +2, and calcium, which is +2. They both carry the same charge, so therefore if we inject them into an IC system, we want to be able that we can get a signal from only one of these, not from a combination of both. So can we separate them, and can we identify them? Same thing happens on the negative side. As you can imagine, we've got fluoride, which is -1. We've got chloride, which is a -1. We have bromide, which is a -1, right? Just again, another example. So can this machine maybe hone in on chloride and tell me if it's present? And then will that machine be able to separate chloride from the rat pack of all of the other -1s that might be present in the sample? We can't take any chances. Procedures say blank, so use the solvent, and then standards and samples. It says dilute with water or other solvents if that's appropriate. And then run a blank and a standard in your sample, making sure that you have something that says, yes, this has it. Yes, we get a positive signal. Yes, we see it. And then the sample after that, meaning we don't quite know for sure if this has it, but we know that our standard work. So if this works, we feel really good about it. If it doesn't work, we feel really good about it. It's not there. All right. Next up, as far as drawbacks go, if I had to make a summary, and this is an IC system, by the way, that's what you're seeing someone using here. A lot of the problems with the instrumentation is, of course, the time. So these are not very fast analysis times. So with the time, don't be surprised if these things take 30 minutes or more in order to process one sample. I don't know how many I could probably do in 30 minutes by hand. Probably tons, right? But this is the drawback of some of the instrumentation that you begin to use. Next is money. So when I say money, yeah, the instrument, cha-ching, 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 costs quite a bit of money. But a lot of times, all of the components that are on the inside of this thing is also going to cost quite a bit of money if we're not very careful. So you really do have to make an investment up front. And that investment could be a couple of thousands of dollars that you have to eat through every few months, because some of these are not permanent things that will stay and last forever. So money is also an issue. Compare that to general reagents that are just solutions that I can quickly make and then just dump what I don't need. It's not going to be very wasteful as far as the wallet goes, but those are very often much cheaper to do than the instrumentation pieces listed in 191. Next up is validation. This is something I don't really do, quite honestly, this whole entire validation step with reagent-based identification test, but instrumentation does need validated, and it does need to make sure that it's working the proper way. Next up is calibration as well. That could be a different thing. And that calibration is making sure that it's seeing things on scale or in proportion that it needs to see them. So as I make stronger concentrations of something, does that machine go up and up and up? That is a calibration technique. The other thing is like a balance needs to be calibrated too, right? So the calibration would be putting some weights onto a scale, making sure that that weight is the number that's the readout on the balance. So these things, if it's not, we got to go through, we got to calibrate it, we got to fine tune it, we got to make sure that it's back in line and giving us proper readouts of values that we see on the reports or the receipts. And then finally, the other thing or the other drawback with the instrumentation courses of 191 is just simply trained people. Not everyone can go into the lab and just automatically know how to use some of this instrumentation. So very often it requires training. That training is going to be SOPs. That training has to be done by professional people. You have to prove that you're using the machine the right way before you're cleared out on using it. So there's a whole process about onboarding and training that a laboratory has to go through to make sure that you really do know how to use some of the instrumentation that you're using in the identification test. That necessarily doesn't really happen on the reagent side of the house. There is way more training that has to be performed on the instrumentation side versus on the chemical reagent side of add a few drops and tell me what you see. So overall, these are the drawbacks. I've alluded to some of these throughout our discussion together so far, and this just kind of sums it all up into one nice little chunk of information. If I go back to the 191, again, you're going to see this section here on the back side of 191, instrumentation identification test. And this is where they start listing all the different ones. So X-ray fluorescence we do not have. And then we see the section of atomic absorption and atomic emission and inductively coupled plasma. So all of the metal analysis pieces, we will see that chunk of information here. General overview, that's all that this is. That's all that they really provide. Next up is the ion chromatography piece. And again, we have that in-house as well. Cations are okay. Anions are okay here. It is chromatography, so not only do we have to look at ion chromatography, but simply chromatography in general. And once more, we go into way more detail in the chromatography side of the class or the side of the program. Raman spectroscopy follows that, and then finally infrared spectroscopy here at the end of the document. So again, general overview, brief introduction. Mid-infrared spectroscopy techniques can be used for identification of counter-ions. Guidance regarding the use of mid-infrared spectroscopy may be found in blah, 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 blah. This is, again, the idea. Here's a purpose. Here's some background. This is an intro. But really, if you want to dig deeper into those instrumentation pieces, they're going to give you references to go by. And these references, you would have to kind of go to those sections, and that is where pages of information will be detailed on that specific types of test. So we're going to visit some of these, especially in 197. We're going to see 197 is spectroscopic identification test. We will venture into that, and we will look at details, and we'll look at what they'll talk about. But as of now, we're only focused on 191, and that is it, right? So identification test, that's all that we've been talking about. Major test, things that are supposed to be there, very quick test that we can do to ensure that those things are there. And if it fails the identification test, we probably, again, do not need to go any further, because that means the major part of what should be here probably is not here. And that is what the ID tests are all about. So once again, if I go to a proper monograph, that is one of the reasons they stick this in the very front of these monographs, because they would like for you to do these first, right? And that's going to give you the big clearance of absolutely no, there's no chloride in your hydrochloric acid. Sorry, you got something else in the jug, but it's not hydrochloric acid. Why waste your time on the other things if you know that that's the case? So that's going to sum up identification test. Again, 191 is going to be this reference code. We will see 191 many, many times, and we'll talk about some of the specific 191 tests in the laboratory lectures that you will see as you do these tests, or after the fact. After you do the test, you'll kind of get a breakdown of what really is going on to give you a taste and flavor of what these reactions are really doing. So with that said, we're done with 191. Hopefully that will kind of help you understand the purpose of this section of the USPNF. And then the next videos we'll venture on and we look at other chapters like this that we can kind of pick apart, talk about why they're there, and maybe a little bit more detail of what's going on. All right, so maybe take a break, study for that 191 quiz, because you know it's going to happen, and be ready for those questions. And then I'll see you in the next one. Have fun. Good luck. Bye-bye.